Assalamualaikum to Sir HAMZI. My name is Muhammad Izzuddin bin Muhammad Anuar. My matrix number is 01DDT23F1187. And today me and my two other partners are going to present the case study for the course EFN 40232 Fiber Optic Communication System. Without further ado, let's begin. First of all, we need to take a look at the given situation. You are an entrepreneur who recently started a fiber optic installation and maintenance business. Your company provides high-speed fiber optic internet solutions to urban and rural areas. You have a growing team of engineers and technicians who handle the fiber optic system installations, troubleshooting and maintenance. Recently, a client has requested a detailed proposal for installing a fiber optic communication system in their headquarters. The system must ensure high efficiency, reliability and cost effectiveness. Now let's take a look at question 1, which is system design and components. Draw and explain the block diagram of a fiber optic communication system that you would propose for the client. So this is the diagram block that we have just drew. So we got message origin, transmitter block, optical source, optical fiber link, optical receiver, receiver block and splicing / connectors, and also message output. So the flow of the diagram started with message origin, and then it goes to optical source, and then it goes to optical fiber link, and then to splicing connectors, and then to optical receiver, and then lastly to message output. Identify and describe the key components, optical source, optical receiver, connectors and splicing methods used in your proposed system. So the first one we got is message origin. The function is as the starting point of the communication where the data originates. For example, a computer, telephone or any digital or analog source. The second one is optical source. It is within the transmitter block. Its function is to convert the electrical signal into an optical signal. So we decided to use injection laser diodes. And the third one is optical fiber link. Its function is to transmit the light signal over distances using optical fiber. The type of fiber that we use is single mode fiber because it is suitable for long distance and it also has high bandwidth. The benefit of optical fiber link is it is immune to electromagnetic interference and also have low signal loss. And the fourth one is splicing / connectors. The function of connectors is to connect or extend fiber cables or link them to devices. So the method of splicing that we decided to use is fusion splicing because it is permanent and it also has low loss joints. The type of connectors that we are going to use are either LC or SC types because both of them allow for flexible disconnection or rerouting. And the fifth one is optical receiver. Its function is to convert the light signal back into an electrical signal. So we decided to use avalanche photodiodes, and the benefit of avalanche photodiodes is it has fast response time and also has high sensitivity. And the last one is message output. Its function is as the final destination of the communication processed and usable by computers or voice system. Now let's take a look at the second question, which is technical decision making. Based on the client's requirements, decide whether to use LED or injection laser diodes (ILDs) as optical sources. Justify your choice. Injection laser diodes (ILDs) are the preferred optical source for this project due to their high-speed data transmission, greater reliability, and efficient light coupling into optical fibers. Unlike LEDs, which are limited in speed and distance, ILDs offer narrow spectral output, coherent light and higher power, making them ideal for long distance, high performance communication systems. Choose between PIN photodiode and avalanche photodiode APD as an optical detector for this project. Provide reasons for your selection. The Avanche photodiode APD is the better choice as an optical detector because of its higher sensitivity and internal signal amplification. Compared to a pin photodiode, the APD can detect weaker signals, which is essential in high-speed or long-range optical network. Although it requires a higher operating voltage, the APD delivers better performance and signal quality, making it more suitable for demanding communication environments. Now let's take a look at the third question, which is installation and management. Explain the different fiber optic connectors FC, ST, SCLC that your team will use in this installation. So the first one is FC connector, or also known as ferrule connector. Its design is screw type connection with a threaded body. The use case is common in high vibration environments due to secure locking. Its advantages is durable and good signal stability, and its limitations is slower to connect and disconnect, and it is also bulkier. And then the second type is ST, also known as straight tip. Its design is bayonet style connector with a twist lock mechanism. Its use case is often found in legacy systems or network backbones. Its advantages is easy to install and reliable connection. The limitation of it is prone to disconnection if not locked properly. The third type is SC connector, or also known as subscriber connector or square connector. Its design is push-pull type, and it also has a square shaped body. Its use case is popular in data centers and telecom. Its advantages are quick installation, low signal loss, and affordable. And its limitations are larger size than LC connector, and it takes up more panel space. And the last type is LC connector, or also known as lucent connector or little connector. Its design is small form factor and push-pull style. Its use case is ideal for high-density environments, patch panels, and switch ports. Its advantages are compact, excellent performance, and common in modern setups. And its limitations is slightly more expensive than SC and also justified for space savings. But justified for space savings. Your team must perform splicing for the fiber optic cables. Would you prefer arc fusion splicing or mechanical splicing? Explain your choice based on cost, efficiency, and durability. So for this installation, our team will be using arc fusion splicing over mechanical splicing. Although it has a higher upfront cost and requires skilled operation, it offers low signal loss, greater durability, and long-term reliability. Unlike mechanical splicing, which is quicker but less stable, arc fusion ensures a strong, permanent connection, ideal for a high-speed fiber optic system like the one required for the client's headquarters. Now I'm going to pass this presentation to my partner AQIL to continue the presentation. That is all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad AQIL. My matrix number is 01DDT23F1113. And today I'm going to presenting and explaining about question 4 and question 7 from our case study. So for question 4, problem solving and innovation. So the question is, during installation, your team face signal loss due to improper source to fiber coupling. How will you resolve this? So how can we resolve it? So we can carefully realign the fiber with the optical source to maximize light injection. And the second one is we can inspect connectors and fibers for cleanliness or damage and immediately do the cleaning or replacing if needed. And the last one is employ precision alignment tools and power meters to optimize the coupling. And the second question for this fourth part of the Case study, if a competitor offers lower cost fiber optic installation, how will you differentiate your business to remain competitive while maintaining quality service? So how we differentiate our business to remain competitive? We emphasize the company commitment to high quality installation and reliable post-installation support and provide value-added service such as regular maintenance and proactive monitoring to our client fiber optic for a period of time.
Assalamualaikum warahmatullahi wabarakatuh and good afternoon to my lecturer, Tuan Muhammad HAMZI bin Muhammad SAFIAN. My name is Muhammad Umar bin SHAZALI, matrix number 01DDT23F1189. And today I will be continuing the case study for fiber optic communication system. Okay. For question 5, selecting and right testing equipment. Okay, for my team has access to various fiber optic test equipment including visual cable fault locator, fiber optic power meter, and optical loss test set. Okay, so what are these? What are the use of these equipments? Okay, okay. For what are the usage of the visual cable fault locator is to quickly identify or breaks or bends in the fiber. The fiber optic power meter help measure signal strength at different points to verify performance. And the optical loss test set is to measure total optical loss to ensure compliance with system specs. Okay. For question 6, power measurement and loss analysis. Explain the importance of decibel, dB, dBW, and dBm in power measurements for fiber optic system. Okay. For the decibel, dB is a logarithmic unit that expresses the ratio between two power levels and used to describe gain or loss in a system. For example, the signal attenuation or amplifier gain. Okay, for decibel milliwatts, dBf is an absolute power measurement a reference to 1 milliwatt commonly used in fiber optics to indicate signal power levels. And decibel watts dBW, also an absolute power measurement but reference to 1 watt, but and not as commonly used in fiber optics as dBm. Okay, the questions that we receive are: given that the input power of the transmitter is 10 dBm and the receiver sensitivity is negative 25 dBm, calculate the power budget for the system. Okay, so the calculation is the transmitter power minus the receiver sensitivity, and so the total is 35 decibel, 35 decibels. Okay, it means the system can tolerate up to 35 of total loss before the signal drops below the receiver sensitivity. Okay, then if there is insertion loss of 2 dB per connector and 0.1 dB per splice, determine the total power loss in the system as 4 connectors and 10 splice. Okay, for the total power loss, this is the equation. 4 times 4 connectors times 2 decibels and 10 splice times 0.1 decibels, 8 minus 8 plus 1, so the total is 9 decibels. Okay, so thank you, that is all from me.
For question 7, and now I will presenting our question 7, entrepreneurial and managerial decision making. So the first question is, as an entrepreneur, how will you ensure cost effectiveness while maintaining high system performance? So we ensure cost effectiveness while maintaining system performance by carefully select cost effective components without compromising quality of the fiber or the other components too much. The second one is we optimize installation process to reduce labor costs and time that it takes. And the last one is implement efficient project management to avoid delays and budget overruns. And the second question is, what strategies will you use to manage your workforce and resource effectively during the project implementation. So the strategy that can be used is we will develop a detailed project plan with clear timelines and objective and assign tasks but based on individual expertise and skills. The third one is monitor progress regularly and solve any issue that been addressed immediately. And the last one is we are going to optimize resources allocation to maximize productivity. And the last question for this seven part of our case study, how will you differentiate your business from competitors in fiber optic industry? So our business can be differentiate from other competitors uh, by uh, we focus on providing superior customer service and support better than our competitors. And the second one is always investing in the latest technology and adapt to the latest technology in the industry. And the last one is offer specialized services to the clients such as customized network design and emergency repair service. And that's all from me. Thank you very much for listening.